No, that's not our final exam. Don't. Yeah. Look at the timing of that. Yeah. Yeah. That would be disturbing. All right. So for this class, our final exam. Oh, somebody asked me that question, so let me answer that question by going to the ARC website, because I cannot make up the date of the final exam. I have to follow the college scheduling. Calendar.
The black bar.
Oh, but it will show it here too.
Yeah.
Okay, so according to this calendar, this class is a day class. It starts at 10:30. It's a Tuesday, Thursday class. So we are looking at this bar here. So our final exam is going to be on the 15th. It'll be a Thursday. The time is from 10:15 to 12:15, so it'll be 2 hours. Any questions about the final exam? No questions? Yep.
You'll tell us again?
I will remind you guys again. There will be a practice final before the final exam, so you guys will definitely know it by the time when it comes.
Right now.
Yep.
Are you going to take it in class, or is your last 10?
I'm thinking that we might be able to take it, in the lab, but past experience has taught me, that may not be a good idea.
We've done all the tests.
Because we are not used to it. We are not used to the lab machine, so it will be hard for some people to find open office, and and I also learned that sometimes the browser at the lab also tend to crash. I'm not sure whether they have fixed that problem or not, but doing on paper is actually more reliable. I mean, so we'll probably end up doing it on paper. All right, so that is that. So we're going to continue and talk about the binary search algorithm. We actually finished that already last time, the binary search algorithm. Are there any questions so far about the topics that we have talked about? Mostly about arrays and questions about arrays. Because binary search, it was pretty much the last topic in searching in a sorted array. And there's nothing beyond that. No questions? If there are no questions, we're going to move on to talk about subroutines. And this is a brand new topic. It's also a very important topic when we talk about subroutines. So let's go ahead and start on this part here. Subroutine is a control flow mechanism. In other words, this is a concept that is in a certain way related to loops and conditional statements and whatnot, because it dictates, after this line, where do we go? After this line, where do we go? Subroutine, is about that. But what subroutines are useful for is abstraction. Have we talked about abstraction in this class? How about top-down design? We talked about top-down design. Okay, so let's go ahead and let me just use an example to illustrate what a subroutine is, and also how those concepts apply. And we'll just use a spreadsheet. And I don't think I need to remember that. All right. So what I'll do is I'm going to write an algorithm that has a subroutine and illustrate what it is, and why it is useful. A subroutine starts with define sub, in this class in pseudocode, and I'll just call this subroutine increment x. And inside the subroutine, all I'm going to do is to say, well, let me make this more interesting. I'll say if x is x gets x plus 1. However, if x is greater than or equal to, let's say 3, then x becomes 0 again. And if, and define sub. I'll fix the indentation and then talk about, what is this code actually doing. So here's the indentation, his indentation. Okay. Let's not worry about line 1 and line 6 for the time being. Let's just focus on the content of the subroutine, which is from line 2 to line 5. This is what I usually, what is also called a modulus increment. In other words, if you just keep, doing this, adding 1 to x, check whether it is greater than or equal to 3. If it is, you reset it back to 0. Assuming x is always positive, that means x can only have the values of 0, 1, 2, because by the time it gets to 3, it gets dialed back or reset back to 0. Is that making any sense so far? Okay. So that's what my increment x subroutine is doing. Now let's go back and talk about what is line 1 and line 6 doing. Line 1 and line 6 are basically matching parentheses. One to start the definition of a subroutine, the other one to mark the end of a subroutine. What a subroutine is a collection of code. Okay, it's basically just like our regular code, but it doesn't execute until somebody says, oh, by the way, let's go execute the program or the code in increment x. In other words, this is more like definitions in a dictionary. Most of the time, we don't care about it. Okay, it's just sitting there doing nothing. Only when you say, oh, I want to do that action called increment x, then this code will execute. Are we doing okay so far with the basic concept? Let's take a look at the rest of this program. The rest of this program, the first line is I will initialize x to a certain value. Let's say we initialize it to 1. And then we'll invoke the code or invoke the subroutine called increment x here. And we'll go ahead and print the value of x here, and then we'll invoke it again. Yep.
Okay. So that's line 7 right after the thing finishes and x goes to 0. And
Say again?
Okay, if you start from the beginning after line 6, then on line 7, x becomes 1. It went to 0, now it becomes 1.
Well, when we trace the code, we'll find out what it does.
Okay.
So I'll answer your question as we trace this code. Okay. Well, remember what I said. When you see the definition of a subroutine, in this case from line 1 to line 6 is the definition of a subroutine. The definition doesn't do anything at all until the main program invokes it. So that means we don't start executing on line 1. We don't start execution on line 2. In fact, we don't do anything until we get to line 7. Because any code in the definition of a subroutine remains quote-unquote dormant as only a part of a definition. You don't execute it until it is invoked. That's what the invoke is to say, oh, I want that code to execute now. But now we have 2 places in the same program. On line 8, I wanted to do it. On line 10, I also want the same code to execute. Are we doing okay so far? In other words, there are 2 places in this program that I want to use the modulus increment subroutine. Yep.
Is this different from a function?
It is actually just a function. So if you already understand what a function or procedure is in the regular programming language, that's exactly what it is. But in this class, I don't just explain the behavior. I also explain what is happening behind the scene that allows this to happen. So so even though you already understand the concept, now you will actually see how it all happens. What the program or what the computer has to track in order to make this happen. But yes, you are correct. This is a function.
Okay.
Yep. Okay. All right. So line 7 in this case is really the first line to execute because it's the first line that is outside the definition of a subroutine. Are we doing okay so far? You don't start executing the code inside the definition of a subroutine until it is invoked or called. Okay, there are 2 words to refer to activating the code. You can invoke a subroutine. You can also call a subroutine. They mean the same thing.
Subroutines, you gotta have them also at the very beginning of your code every time, like how you have it. So your stuff is always at the beginning.
No, you can. Well, it depends on the programming language. Most programming languages, most scripting languages, will allow you to place the subroutine definition anywhere you want. So you can actually define the subroutine after you have code to invoke the subroutine. And I just want to make sure the recorder is up and running. Go ahead.
So the computer will just search for the invoke line
Correct.
that corresponds with what you're.
Well, no. Okay, I take it back. The computer is still executing the program sequentially, from top to bottom, but it doesn't execute the code inside the subroutine, inside the subroutine definition, until we get to line 8. But we start with line 7, so we are not there yet.
So the define always has to come first.
No, you can move this entire block, anywhere in the program. It depends on the programming language in that case. It's language dependent.
But it'll search for it, and then if it says invoke that, it'll search through the whole program for define that or whatever.
Something like that. It depends on the language too. In some cases, if you use a compiled language, it is already found. It already knows where to find it. When you use a scripting language, then quote unquote, it has to find it. Go ahead.
Just got my head there.
Oh,
I don't have a question.
okay. All right. All right, so let's go ahead and run this program and see what happens, because the trace is what makes this program interesting. So we'll go ahead and trace this. We'll call this sub1, because we'll have multiple programs that has subroutines in it. And we'll use sheet 2 for our trace. Okay. So in this case, we have comments, because we do have one conditional statement. We have our usual line number. We have X to start with. So all of these things, we have to start with these particular columns. And use our precondition is that we don't know anything about X, because the first thing we do is to initialize the value of X. So as I said a little bit earlier, we don't start executing the code inside the definition of a subroutine. It remains dormant. So that means the first line we execute in this program is line 7. Okay? Line 7 is going to initialize X to 1. There's nothing new at this point except the fact that we don't start execution inside the subroutine inside the definition of a subroutine. Now we move on to line 8. Line 8 is very special because it seems to do something that a tabooed feature of programming language does. It seems to do what goto does. Okay? In other words, when we execute line 8, we'll continue execution on line 2. Okay? So we'll go ahead and leave some space here, and then we go to line 2.
Why do you leave space?
Because I got some stuff to fill in here.
I'm going to try to leave space too. I'm going to see.
Yes, if you're taking notes, you should leave some space.
Like one space?
Yeah, just leave one row. Okay. But the effect at this point is when you execute line 8, it will continue execution in the definition of the subroutine that matches the name increment X. Is that okay? So line 8 is here. It identifies that we want to invoke the subroutine increment X. We find the definition of increment X here, and as a result, we continue execution on line 2. Is that okay so far? Okay. This part is usually not very difficult. People can make the association, invoke blah 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 name. We look for the definition of blah 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 and continue execution in the subroutine. That part is easy. Line 2 doesn't do anything too fancy either. It adds 1 to X. X goes from 1 to 2. We go to line 3. All the usual stuff. This is nothing surprising. X is greater than or equal to 3 is false because it is 2. And then we skip the entire thing and we end up on line 6. Now we have a problem. Where am I supposed to go back to?
Line 9.
Why? Where?
Line 9.
Line 9. Now, how do you know that we are supposed to go back to line 9?
Because if you go back to 8, you're going to have an endless loop. You're going to endlessly invoke.
But nowhere in the trace tells me that I'm supposed to go back to line 9.
In your invoke statement, it has something that does that.
Okay. Well, let's say we know magically, we know that we are supposed to go back to line 9. Line 9 is nothing special either. All it does is to print the value of x to the screen. So we just say print the value of 2 because x has a value of 2 at this point. And then on line 10, what do? We invoke increment x again, right? Okay, so we'll invoke. And remember what I said, when you invoke a subroutine, it's kind of like doing a goto. You look for the definition increment x, and then you continue execution into that definition. So in this case, where am I supposed to continue execution?
Post. Oh, 2 and then.
Line 2, because I'm invoking increment x, on line 10, so I have to continue execution on line 2. Line 2 doesn't do anything too fancy. It adds 1 to x. X goes from 2 to 3. On line 3, it has a condition to evaluate. X is greater than or equal to 3. This time is true. We get into the subroutine, and we get into the conditional statement on line 4. We reset the value of x to 0, and then we get out of the conditional statement. We get to line 6 again, and this time where am I supposed to go?
Post.
We're supposed to go to post. Well, I have a problem here. I have a problem here because how am I supposed to know that sometimes after the subroutine, I'm supposed to go to line 9, and sometimes I'm supposed to go to post? There's nothing in this trace that tells me where to go after line 6. That means the trace, and that's why we have those empty rows. The empty rows are here because now I'm going back to say, oh, okay, I forgot to do something in the trace so that I remember where I'm supposed to go back to. As it turns out, when you execute line 8, when you execute a invoke statement, going to the definition of increment x is a second step. There's one step you have to do first. The first step is to allocate a new column. This is something that we haven't done before, okay? Up to this point, all the columns are pre-allocated. Oh, we need 7 columns because we have an array, 2 variables, and a line number. We already know the number of columns that we need up to this point. But when we deal with subroutines, we have to allocate and deallocate columns on the fly as we execute the program. So in this case, when we execute line 8, we have to allocate a new column, and then we say, okay, we'll use this column to remember the return line number. Okay? Because at this point, I know where I'm supposed to return to. I'm still at the point before I go and continue execution in the subroutine called increment x. So I can, right away, I can say, let's go back to line 9 when the subroutine is all done. Are we doing okay so far with these 2 cells? The meaning of these 2 cells. So we dynamically allocate another column and say that, oh, I have something that I have to remember, and therefore I need to allocate a new column. Yep.
So we know the line numbers because it's sequential.
We know the line number because in this case, when you invoke a subroutine, you always continue execution in the next line, on the next line, or the line that is logically following the invoke statement.
Could the invoke statement change our number, the line number that we go to?
The invoke statement has to change this. So let's see what this does. Okay.
Could it like call? You get called into one, and that can send you to a different one. I don't know if that makes sense.
Yes, this cell can change depending on where you are when you invoke. Okay, so we'll see that. We'll see that in this example. Okay, so this is all that I was adding, but I'll highlight it. Yep, go ahead.
In Visual Basic, when you call a subroutine, it executes the subroutine and returns back to the call, then goes to the next number, the line.
Correct. We'll address that later on when we talk about return values, because this is simplified,
Right.
but we will talk about that when we have function that returns a value. So for the time being, we just say that we return to the line that is logically following the invoke statement. All right, so with column D in place, then this part here on line 6 is no longer mysterious. Because on line 6, when we execute line 6, which is end define sub, all I have to do is to look up and say, hey, did I remember where I'm supposed to go back to? Oh yeah, we have a column called return line number. So let's look up the most recent return line number column and use that to tell me where I'm supposed to go back to.
Go.
Okay, in this case, we go back to line 9.
Go to 9.
Yep. But at the same time, there's one more thing we have to do. We have to say that this column is no longer in use at this point. So if I want to use formatting to indicate that, I'll use a strike through. So let's see, where is my strike through? I want to format characters, but it's not. Okay, I guess I have to highlight, format, character, font effect. You don't have to go through all this stuff here, but I'm using this to indicate this column is now deallocated. Because once I utilize the fact that I have to go back to line 9 and I go back to line 9, this column D, is not useful to me anymore. So I deallocate that column so I can reuse it later on. Are we doing okay so far? Okay. We go to line 9. Line 9 doesn't do any invocation. All it does is to print the value of x. No big deal. On line 10, it is invoking again. So once again, when you invoke a subroutine, there are two things to do. One, the first thing is to allocate a new column, label it return line number, and then remember where you're supposed to go back to when the subroutine is done. The second thing you do is to continue execution at the subroutine. Okay, so let's do this. First thing first, we have to allocate a column. This time we are reusing column D because column D at this point is free. It's not in use anymore. Yep.
So we return the post.
Yes, we will say that post is where we are supposed to go back to, and then we continue execution in the subroutine. The order is important. You always have to remember where you're supposed to go back to, then you continue execution in the definition of the subroutine. And then at the end of this subroutine, we do exactly the same thing. We look up the return line number column. In this case, it tells me to continue execution at post, and that's where we are going. But after we look up the fact that we have to continue execution at post, we can also say that this column is no longer useful to me anymore, and now it is deallocated. Are we doing okay so far with this concept? Now, if I have to use highlighting or the background color to indicate when column D is actually in use, this will be the first block that I have to highlight. And then this will be the second block. There, just like that. So basically, column D is in use from row 4 to row 8, and also from row 10 to row 15 of the trace. Are we doing okay so far with the concept of subroutines? The definition is nothing more than a block of code that has a name attached to it. But it doesn't execute until the program invokes it.
There can be subroutines within subroutines, right? Can there be subroutines within?
Well, let's make that our next example, is to have a subroutine in a subroutine. But when you say a subroutine inside a subroutine, there are multiple ways to interpret what your statement. Invoke inside the invoke.
Yeah, you invoke inside it.
Sure, we can do that. Let me save this one first, and then we'll move on to the next one. I'll keep that one around, just so that we can refer to it in case we want to. In the second one, we'll have a subroutine invoking a subroutine, okay? Or inside one subroutine, we invoke another subroutine. So we'll say define sub, increment x, and this one we just say x gets x plus 1, and define sub. And then we'll have another subroutine called modulus increment x. And this one will first invoke the usual increment x. Then it will go through the conditional statement. In other words, the logic is the same as the program before, except it is organized a little bit differently. Okay. And we'll just go ahead and indent the code that we should. Indent, like that. So let's take a look at this at these definitions right now. The first subroutine is called increment x. Obviously, that one is really simple. Only has one single assignment statement to increment the value of x. The second definition is mod or modulus increment x. And this one is a little bit different because the first thing it does is to invoke another subroutine first. Can't enter the uppercase x. Hey. It doesn't let me do it. I'm actually typing. Oh, okay, there we go.
Caps lock on?
Yeah, something like that. Operator error. Okay, so in this case, the second subroutine will invoke the first subroutine first, and then it will continue on with the conditional statement. And then the main program, I'll make this one simpler. In the main program, we'll just go ahead and initialize x first. This time, let's initialize it to 2. And then we'll go ahead and invoke mod increment x. And just for fun, we're going to increment x after that. Okay, just for fun, just to show that you don't have to go through the second subroutine to invoke the first one. Yep, go ahead.
How come it doesn't say end-defined sub mod increment x or end-defined sub increment x?
The end is just indicating it's the end of a subroutine definition.
It doesn't have to correspond with the beginning.
It's pseudocode if you want to. If you want to add the name, that's fine. In this class, it's all, as long as we understand what is ending, we're fine.
I write it. I get it. All right.
So if you want to add, end define sub and increment x, that's fine too. Because it really is just pseudocode.
In programming, you actually do that, though, don't you?
Now, in an actual programming language, it depends on the
Brackets.
syntax. You use curly braces in some language. In some languages, you just change the indentation. So it depends on which programming language you're using. But in this case, it's all pseudocode, so it doesn't really matter. Okay. And it's a good time to make sure we save this file first. I'll call this sub2. And we'll go ahead and trace it. Just like the last one, we have comments, we have line number, and then we have x. These have to be predefined because they are not created on the fly. These are always there as soon as you execute the program. All right, we start with pre, and x is unknown to begin with. Then we move on to, which line should we start with? 10, because line 10 is the first line that is not inside the definition of a subroutine. So we start with line 10. Line 10 is going to put a value of 2 into x, and that's all it does. Then we go to line 11. Line 11 is an invoke statement. Tell me what 2 things do we have to do when we invoke a statement. First thing first is return line number. Okay, we allocate a new column. We allocate a new column, but we have to make sure that we allocate not column E or column F. We have to allocate the column that is closest to the left-hand side. So in this case, we have to allocate column D because that's the next available column to allocate. And what am I supposed to write in column D now that I have it allocated? Where am I supposed to go back to when I'm done with the invoke on line 11?
Line 12.
We go back to line 12. Very good. So we just write down line 12 here so that we now remember where to go back to when the subroutine is done. And then what is the second step of invoking a subroutine? Continue execution in the definition. All right. So in this case, the definition of mod increment x is line 5. So we continue execution on line 5. Oh, well, guess what line 5 does?
Invokes the next one.
It invokes another statement. So what am I supposed to do again? Yep.
Return line goes to E.
Well, okay. Now there are several things that are important. Okay. Yes, you got that part right. But the question is, where am I supposed to remember that we are supposed to go back to line 6?
Allocate a new column.
Allocate a new column. Very good. Okay, so column D is already in use at this point. I cannot reuse column D at this point. So the next available column, the next leftmost available column is column E. So column E is the one that I allocate at this point. It is return line number, and because the invoke is on line 5, we have to go to line 6 when we're done. All right. Are we doing okay so far? Any questions? No questions? Okay. All right. So now that we know where to go back to after increment x is done, we continue execution in the definition of the subroutine, which in this case is line 2. Line 2 doesn't do anything fancy. All it does is to add 1 to x. X goes from 2 to 3. And then we go to line 3. Line 3 and define sub only does one thing. I mean, two things. The first thing is it looks up a column with the label of return line number. But hey, we have a problem here. We have two columns that are both labeled return line number.
They're the most right.
It uses the rightmost return line number column. Okay? But it makes sense, right? It's the most recently created return line number. So when you want to use it, you have to use the most recently created return line number. In this case, it is column E. So line 3, when we execute line 3, it will use column E to say that, oh, we have to continue execution on line 6. So that's why the next line to execute is line 6. But don't forget the second step of returning from a subroutine or finishing with a subroutine is to make sure that this particular line is no longer, this column is now deallocated. So we'll go ahead and indicate it is deallocated by, I use strike through because it is actually more obvious what I'm deallocating. At this point, it doesn't seem to be necessary to indicate this is the column that we are deallocating, but later on it will be more significant. Now that we are on line 6, we just execute the usual conditional statement. X is greater than or equal to 3 is true because x is 3 at this point. So we have to go into the conditional statement onto line 7, change the value of x to 0, and then we get out of the conditional statement, and then we go to line 9. Line 9 is n-defined sub 2, and it has to look up a return line number column. Which one am I supposed to use?
Well,
The rightmost available one. But how come we are not using column E anymore? It's already used. Okay, it is already used, and the strike through indicates that that column is no longer in use anymore. So the most recently created return line number column that is still in use is column D. So column D tells us to continue execution on line 12, and then after that we also have to remember to indicate that this column is now not in use anymore. It is deallocated. Okay? Now we continue execution on line 12. What does line 12 do? It invokes again. Okay?
But you can do it on the same line, right? On the line D.
Well, we use the same method. We allocate the leftmost column that is available. The leftmost column that is available turns out to be D because we just deallocated it. So now we can reallocate it to remember where we're supposed to go back to. So now we reallocate column D to remember after increment x is done, there's nothing else to do, we just return to post. Then we can continue execution inside the subroutine that we are invoking and continue on to line 2 in this case. X gets incremented from 0 to 1. Then we go to line 3. Line 3 is going to look up the most recently created column that has a return line number, and that's column D in this case. Column D tells me to continue onto post, and then this column, once again, is no longer in use, and then we continue onto post, and we are done. That's subroutine. The basics of subroutine is like this. Any questions about the mechanical aspect of a subroutine? Yep.
so there's no no way to change the return line once you're in a subroutine.
That is correct. That is correct. You will learn how to do what you just said, to change the return point when you get to the assembly programming class. The assembly language programming class will explain certain things. Okay, the next class that you're taking is cisp300. And there will be chances, okay, I'm not saying that everybody will encounter that problem, but some of you will encounter a problem that cannot be explained by this class or cisp300. Your program will behave in very odd ways that cannot be explained. The explanation will come in cisp310, the assembly language programming class. Okay, so certain things you will see this again in cisp310. I'm teaching cisp310, so I assure you that we'll see something like this again. Okay, so are we doing good with sub 2? We're invoking a subroutine inside the definition of a subroutine. And as it turns out, did we change the mechanism of invoking a subroutine? Did we change the mechanism of coming back from a subroutine? Okay, so that means from now on, I will sound like a broken record. Once you get the mechanism down, no matter how weird your program looks, it will still behave the same way. Okay? So the next program is going to look very weird. But if you follow these rules and just do what we just talked about, you will be able to track it without any problems. So let's take a look at this one. Yep, go ahead.
Just take your time and do the steps, pretty much.
Well, define sub. Yep, exactly. All you have to do is to perform the steps the way that I just described it. Okay. So we'll say, define sub. I'll call this transfer, okay, because it's that's basically what it's doing. And then we'll say if x is greater than 0, then we'll say x gets x minus 1. Invoke transfer. And then we'll say y gets y plus 1. And if, and define sub. Outside we'll say, we'll give x some particular value. We'll give it 2. Okay, that's good enough. Invoke transfer. And now we will go back and fix the indentations. Now this one is interesting in many ways. But in some other ways, it is boring. It's not interesting at all.
Oh, man.
Okay. Can someone point out what makes this program kind of, well, it's weird. It doesn't look like the programs that we have done before.
It invokes itself.
It invokes itself, exactly. From inside transfer, I'm invoking transfer. This is called a recursive subroutine. When a subroutine eventually will invoke itself, it is called a recursive subroutine. Recursive spells R-E-C-U-R-S-I-V-E, recursive. Okay? Recursion, which is the act of calling a recursive subroutine, recursion, is typically a concept that people don't talk about until at the end of CISP360. Yep.
Is the invoke exver indented improperly?
Yep, it is.
No, I mean, line
Oh, the
4.
other one? Oh, you're right. This one should be unindented. But sorry. Thank you. Okay, so this looks kind of mysterious. When I took the first programming class and I saw something like this, I was baffled. Okay, I was baffled by the fact that how can you invoke a subroutine that is not fully defined by the time you execute the invoke statement? But that is not true, because this program is entirely defined already. It's already done. So don't think it that way. Do not overthink. Okay, the worst thing that can happen when you read something like this is to overthink it. What you need to do in this class is just go for the basics. Okay, go for the basics. Remember what we did in the previous two examples. and just apply those mechanisms mechanically the same way as before. That is your ticket out of this program. Let's go ahead and trace it. Now that we have this program, we'll go ahead and trace it, and you will find out that, I will sound like a broken record, trust me. If I don't sound like a broken record when this is all done, something is not right. That's basically how boring programming is.
Why did you get in it?
Because I like boring stuff.
It's not boring. It's because you like it.
Uh-oh. Have to resize the screen again. Window. Here we go. All right. Make sure we save it first because this is the interesting one. Okay. So we'll use sheet 2 to trace this one. Once again, we need comments because there are conditional statements, or there is one conditional statement in this program. We need line number. We have X, and we also have Y in this case. And I forgot to initialize Y first, so let's go ahead and click Y equal to 0 and renumber the lines. Minor changes. Okay, there we go. All right. Precondition, unknown, and unknown. Okay, doesn't matter. What is the first line that I should execute? Line 8, because line 8 is the first line that is not inside the definition of a subroutine. No mystery there. X gets initialized to 2. On line 9, Y gets initialized to 0. No biggie. Now we're on to line 10. Line 10 is invoking transfer. What do we do when we invoke a subroutine? Two things we have to do. One,
Return line.
allocate a new column, mark it as return line number, and then so that we can remember where we're supposed to go back to. Okay? Return line number, we're supposed to go back to post, and then what is the second thing we have to do when we invoke a subroutine? To continue execution inside the definition of the subroutine. In this case, it is line 2. Are we doing okay so far with those two steps? Okay. What do we do on line 2? This is a regular conditional statement. The fact that it is inside the subroutine doesn't change the behavior of a conditional statement. So we still have to evaluate the condition. X is greater than 0 is true. So we go into the conditional statement. We continue on to line 3. Line 3 is going to decrement X by 1. X goes from 2 down to 1. And then we are now on to line 4. Oh, holy smokes, what am I supposed to do now? We are inside transfer and we're invoking transfer. Wait, Tech just said you'll do it mechanically, the same way we did it before. So what do you do when you invoke a subroutine? The two things that you have to do. Allocate a new column. In this case, the new column is going to be column F because column E is in use at this point. Is that okay? We mark it as return line number. And where am I supposed to go back to now that I'm invoking on line 4? We are supposed to go back to line 5. Let's remember that. And then what do we do when you're invoking a subroutine?
Go to number 2.
You continue execution in the definition of the subroutine. Now what I did not make very clear is every time you invoke a subroutine, you start from the beginning of the subroutine. Okay, now that is very important because we are invoking transfer, so that means we have to start with line 2. Okay? Are we doing okay so far? This is the only part that I did not make clear because it was not necessary to make clear before. But now that we are going back to the same subroutine, I have to make it very clear that every time you invoke a subroutine, after you remember where to go back to, you have to continue execution on the first line inside the definition of the subroutine. Are we doing okay so far? Okay. What do we do on line 2? Well, the fact that we are going back to the same subroutine again does not change the behavior of a conditional statement. The conditional statement still does exactly what it did before. It has to compare X to 0. And we say X now has a value of 1. 1 is greater than 0 is true. So guess what you have to do? We go into the then statement, onto line 3. And what does line 3 do? It subtracts 1 from x, no big deal. We locate, variable x, column C, we subtract 1 from it, it goes from 1 all the way down to 0. And then we move on to line 4. What does line 4 do? I mean, isn't this getting a little boring at this point? Line 4 is going to invoke transfer. 2 things we have to do. Remember I said I will sound like a broken record? What do we do when we invoke a subroutine?
Is this going to be a endless loop?
No, it's not endless. It will stop.
0 will be false.
Exactly. You will see. You'll see. So, being a broken record, we have to allocate a new column. This time we are allocating column G because column E and F are both in use at this point. So we have to allocate column G and call it return line number. Where am I supposed to return to? The invoke is on line 4, so the next line is line 5. And then we continue execution inside the subroutine. But remember, when we continue execution inside the subroutine being invoked, we have to start from the beginning every single time. So which line am I supposed to go to? Line 2. Okay. Line 2 is the beginning of a conditional statement. X is greater than 0 is false this time. So that means I don't have to go into the conditional statement. And therefore, we stop the recursion. Okay? The quote-unquote endless invoke stops here because this time X is 0, so we don't have to go in to invoke again. So where do we go if we are not doing anything with the then portion? Yep.
Right.
6.
We go straight to line 6. Very good. Okay.
7.
Line 7.
5.
Correct. Line 7. Line 6 is the end of the conditional statement, but since we don't track the end of a conditional statement, we have to move on to line 7. Line 7 is the end of a subroutine. What 2 things do we have to do when we get to the end of a subroutine? Look up the most recently created return line number. That's the first thing we have to do. In this case, which one is the most recently created? Column G. Okay, column G is the most recently created one. And where is it telling me to go to? Line 5. I mean, to you, it seems kind of odd. I mean, we are going from line 7 back to line 5, but they're in the same subroutine. Remember what I said? Don't overthink. Just follow the mechanism. Okay? And that's exactly what I'm doing. My trace tells me that I have to go back to line 5, and I just go ahead and continue execution on line 5. But there's one more thing I have to do. I have to deallocate column G to remember, hey, this is all used already. Don't go back to this column and use it again in the future. So we'll go ahead and mark it as such. I have to define a shortcut key to do this later.
Why don't you just type returned? Why don't we just type returned?
Why can't you just exit out? I remember you can't just exit out too?
Exit out.
X.
Yeah, but I think this is better because I actually indicate which column is. Yeah, we'll talk. I think this is a better representation than before. Yeah. All right. So we are now on to line 5. What does line 5 do? Line 5 doesn't really do anything that interesting. All it does is to add 1 to y. Y, which had the value of 0, is now 1. And then after line 5, there's nothing else to do in the conditional statement. We continue on to line 7. And line 7 is end define sub. We just blindly follow those two steps again. Look up the rightmost or the most recently created return line number column. Which one are we looking at now?
5.
Column F. Column F, which says we have to continue on to line 5. So we say we continue on to line 5, and then we say this column is no longer in use. I deallocate column F at this point. When we're on line 5, once again, we just add 1 to y. Y is now 1. We add 1 to it, it becomes 2. Then we get out of the conditional statement, get to the end of the subroutine onto line 7, and then we blindly follow those 2 steps again. Look up the most recently created or the rightmost return line number. In this case, it will be column E. Column E tells me to go to post and deallocate once we utilize the content of the column. And now we continue on to post, which means we are all done. You have just traced the first recursive subroutine in this class. Was it hard? The hard part was, I keep saying the same thing again and again, and you have to stay awake. Yes?
What if it's going to be a loop or something?
Well, it is a loop, okay? Now, there are programming languages out there that do not have loops. Okay, Scheme is one. Basically all derivations of Lisp as programming languages do not have loops. This is how they accomplish the same thing as a loop. Use recursion. Okay. Now I can say it right now. Anything you can do with a loop, you can do it with a recursion. Anything you can do with recursion, you can do it with a loop. In other words, in terms of the ability to express an algorithm, they are equivalent. Yep.
What's the difference between, first you said invoke Xfer and invoke just X or inc X?
From the previous trace.
Yeah, from the previous trace.
Just a different name. You just have to match up the name. Yep. You can define a subroutine to be just about any name.
Okay, so that's just a random name.
Yep. Yep. The only restriction is you cannot name two subroutines using the same name, because then when you invoke it, it is not clear which one you want to invoke. But as long as the names of subroutines are unique and the invoke statement has a name that is actually defined, then you are okay. Yep. Are there any questions about sub3? No? Okay, well, the reason why I bring up recursion early on is because if someone claims to understand subroutines, be able to track down the first two examples, but when it comes to recursion, that person cannot track it, that means that person did not truly understand the concepts of subroutines. Because we have not changed the mechanism of invoking. It's still the same boring two steps. We have not changed the steps of coming back from a subroutine. It's the same boring two steps. Right? So if someone can track sub 1 and sub 2, sub 3 should be possible as well. Yep.
There are subroutines inside the loops, so we're going to do that or not.
Subroutines inside a loop?
Yeah.
You mean to invoke a subroutine inside a loop?
Yeah.
Oh, you can easily do that. I mean,
Oh, we're going to have this in the class.
Sometimes we might see that, but that's really just being tedious for the most part. Okay. Are we doing okay with this one? All right. So we are moving forward, really at a good pace, which is good. We are pretty much done with this already. Subroutine, control flow, done. Now we can move on to local variables and parameters. Okay. Now, to show you the problem without local variables and parameters, let's take a look at this program. So we may not have enough time to track down this program today. For those of you who want to do it, you can do it on your own and then tell me what's wrong with this program. Okay, so I'll define a subroutine. We'll call this times 3. Okay. But instead of saying x gets x times 3, I'll do it the long way. The long way is to use a loop to keep adding stuff to itself. So in fact, okay, we'll say
We don't need this term notes, right? This is just, you're not going to define it or not going to...
we won't have enough time to trace it through, but we'll try to see if we. In the next class, we'll trace it and then we'll identify what is the problem with this program. Okay. So let's say we want to use y to store the result. So we'll say y gets y plus x. Oops. Let's define the loop here. While I is less than 3, do y gets y plus x. While and define sub, or better yet, I'll just move that back to x, so x gets y. So this way, the value of x is tripled by the end of this subroutine. Is everybody convinced about that? Is everybody convinced that the value of x will triple by the end of this subroutine?
No.
Oh, I forgot one thing. This is an infinite loop, isn't it? As I said, this is my favorite mistake, and I always watch for that. Forgetting to increment the counter. Okay, but given that I have fixed this on line 5, are you convinced? Oh, I missed one more thing too, because we don't know the value of y to begin with. Fine, we'll fix that. So y gets the value of 0. And since we add x to y 3 times, y should have the value of 3 times x. We copy it back to x. Is that okay?
What about x? What's the value of x? What's the value of x?
We'll give it to, it will be provided by someone outside of the subroutine. Okay. Now, since we know how to multiply something by x, don't you think we can just copy and paste this and say, oh, we now know how to multiply something by 9? In other words, I can say, I want to multiply the value of x by 9. So instead of doing it this way, all I have to do is to say delete this row, and here I have to invoke x3, and I should be done like this. But it won't work. It seems like if you do it 3 times, each time you are tripling, you should end up with multiply by 9, but that's not what it's going to do. Okay, this is a little bit harder to see. Let me change the code a little bit to make it simpler. Just hold on a second. We'll still get out in time. How about instead of multiply by 3, we just say add 3? Okay, add 3 is easier. I gets 0, while I is less than 3, do insert. First thing is x gets x plus 1, I gets I plus 1. I is just a counter, and that's it. Okay, fix the indentations. Okay. Is everybody convinced that this is just going to add 3 to x? Because we are just going through the loop 3 times, and each time it's adding 1 to x, so it's really just incrementing the value of x by 3. If I want to add 9 to the value of x, I just have to invoke add 3 times, and that should get it done. Why not?
Because you're using the same index.
I'm using the same counter,
Right.
and as a result, it will just add 3 to x, and it will call it a day. Okay? Because it looks like it should work, but it's not going to work because the variable I here used in add 9 is really the same variable that add 3 is using. Okay? So it messes up the counting because they are sharing the same variable. Yet, when you look at each individual subroutine, it seems to make sense. When you look at each individual subroutine, it seems to make sense. And that's the worst thing that can happen, because when you look at each piece individually, it looks fine. But when you look at the big picture, it's not fine anymore. Yep?
So you would just more or less carry over an I from the other one
Just
or
use a
something?
different.
Well, we're going to use local variables to fix this problem. So this is the end of this class. I will save this program, and I'll name this in a very special way. I'll call this bad global variable.
Wondering about that. What type of variables were you using right then? I was trying to think of if you were using global or local variables.
By default, we are only using global at this point.
Okay.
Yep.
So X would be something